All right, perfect squares. Before I get into too much depth, I'm just going to quickly whiff through the idea of what perfect squares are. And I want you to understand that you've been doing it since year 7 as well. Everything goes back to year 7, okay? So you got 2 squared, and you got 4 squared, and you got a squared. They're all the same. But visually, what you're really doing is you're saying this. You got 2 squared, which technically is like a square, with side lengths 2 by 2, because this means 2 times 2. But what are you doing when you do 2 times 2? You're actually finding the area of a square, because it has the side lengths 2, 2, and it's all 2. So what you're really doing is you're finding the area of a square. Okay, and that's why it's called a perfect square. Therefore, when you do 4 squared, it's the same thing. It's just a square, larger one, with a length of 4 by 4, and that gives you an area of 16. Okay? And same thing with A, even though it's a different letter, we just don't know what the number is, but technically you're just saying it's a length of A, and therefore this is A squared area. Okay, so when you say A squared, that's an area. That's why when you do, let's say, expansion of, let's say, for example, 2x, actually I'll make it easier, I'll do x plus 1 squared. There's no difference here. What you're saying here is you're saying this. You're saying it's a square with a length of x plus 1 and x plus 1. Just like you did up here, you said that's 2 times 2, this is 4 times 4, this is a times a, then this has to be, yeah, so it becomes x plus 1 times x plus 1, and then you expand this using distributive law. Now, there was a formula for this, and there is a formula for this, and it was called the expanding perfect squares formula, which I can easily give it to you, and you can all do it, but what I want you to see is why it works and what it really is. And what you're really doing here is you're doing this. The formula is if you have a plus b times, what's it called? So a plus b squared. The formula was a squared, so you square the first one, plus 2ab, so you times 2 to a and then times it to b, and then plus b squared. What I don't want you to do is just to look at that formula and go, okay, that's it, I got it. Or even if you knew it and you know how to simplify it, doesn't matter, it doesn't matter to me. Okay, what I want you to understand is what does that represent? What does a squared plus 2ab plus b squared really mean? So if we said that x plus 1 squared is the area of a square, technically this should also be the area of a square. And I'm going to prove it to you. So let's have a look. If we expand this, you're going to say, all right, that becomes x squared, and then that becomes plus x, this becomes plus x, and that becomes plus 1. So you write your answers x squared plus 2x plus 1. Okay? Let's think about it logically now then. If I told you that's the area of a square, well, let's see if it's true. Let's say that from here to here is x. Let's say from here to here is 1. So the entire length must be x plus 1. Let's say do the same thing again. I say this is x, and this is the length of 1. Then this is x plus 1. True? Let's divide it. Let's divide this kind of tofu looking thing, okay? If I divide that, if I asked you, okay, that's x, and that must be x, and this must be 1, this must be x, and this must be 1. If I asked you to find the area of just this little portion, what is that? X times x, which is x squared. Hey, we got that. And if I then did x times 1, so x times 1 here, that gives me the area of this, which is x, which I also got. And then you do x times 1, which is, you also get the area of that. And then 1 times 1 finally gives you the area there, which is 1. So this is what you're really doing. When you write a squared plus 2ab plus b squared, you're really just writing the components of a full square, of a perfect square. That's why it's called the expansion formula for a perfect square. And you're going to keep that in mind for completing the square, because it makes sense why you say complete the square. Okay, but I'm not going to go in more depth than that. I'm just going to leave it there. Just remember, perfect square is literally a square. Okay, so today's session, that's the formula you're going to remember or do, and how they figured it out, because they did the distributive law. So they just had, like a plus b times a plus b, and they literally expanded it themselves, and it found out that it simplifies down to a squared plus 2ab plus b squared. That's where it came from. Okay? Now, All you're going to do in this exercise is you're going to learn to do it quickly, get it proficient, recognize when it's a perfect square so you can easily do it. That's it. Okay, because remember the first exercise was expanding. So if I looked at that, I want you to get to the speed where you can just look at it and say, all right, expansion is square the first one, so x squared, square the last one, which is 25, and 2 times x times 5, 10x. What I don't want you to do is this. X plus 5 times x plus 5, and then you write out x times x is x squared, and then plus 5x plus 5x plus 25, and then you write out x squared plus 10x plus 25. I don't want that. That's what you did in year 8. That's what you did in year 9. Might have learned in year 10. But I want you now to get proficient with this rule. Okay, so let's do a couple of examples now. I just gave you x plus 5 squared. What if I gave you this now? See if you can do this quickly. Let's say x minus 2 squared. What is the answer to this? Can I please have Jen?
Sorry,
X minus 2 squared.
X squared minus 4x minus 4.
No.
4 plus 4.
Plus 4, good. We always square the first one, so it's x squared times 2, so that makes it minus 4x, which is correct. And the last one, don't always make sure to put in the signs in it too, because it's a negative 2. Okay, it's not a positive 2, it's a negative 2, and that is a common one. That's why I put in minus there on purpose. Okay, because that is a common mistake that does happen in the methods and year 12 classes. So when you write it out, use the brackets. Okay, it helps you keep everything organized. All right, so then therefore this becomes plus 4, this becomes minus 4x, and that becomes x squared. All right, let's try. What if I now did this? Let's try. If I increase it to 2x plus 2. What is this going to become? Can I please have Xi'an? Plus. Fantastic. Good. I want you to be at that speed. Okay, so square the first one. So remember, write it out as 2x squared. And then 2 times the 2x, so plus 2 times 2x is 4x. Multiplied to root 2 is root 2. And then squaring the last one, use the brackets. Okay, square and square root cancels out. They're inverses of each other, so you get 4x squared plus 4x root 2 plus 2. Is that easy? Okay, so that's your part of exercise 1A, I mean, is it 1A? 3A. You're just expanding, and in those examples, I just wanted you to do it quickly. Okay, so that's the first one. Second one, difference of perfect squares. Okay, before I get you to go back and finish off question 5, 7, and 8. Okay, difference of perfect squares. I like this one because you use this most in methods, and it's hidden. It's dependent on whether you pick it up or not. And there's a lot of variety. You start off with something easy. You're going to start off with, actually, I'll give you the rule first. This is the rule. And it's simply saying that if you have a perfect square, because that's a perfect square, and that's a perfect square, b squared and a squared, you find the difference between it, technically it gives you this. Okay? What you normally do in your year 9, year 10 textbooks is, which I don't like, is because it does this. It gives you this, it gives you this, it gives you this. Okay? Too easy. Because you're all used to that. That's not learning. That's just you memorizing and just following the rules. But funny enough, most students in my methods class towards the end of the year when I write the tests and SACs, if I changed it to this, they don't see it's the same. See, to a lot of kids, that looks very different. You guys are used to this, but you're not used to this when in fact it's exactly the same.
It's just the fact that it's in the bracket.
Mm-hmm. So these two are exactly the same. This is still A. That's your A. Okay, this is your B. So if we're talking about in terms of, wait, I'm just going to use a different color. This is your A squared minus your B squared. According to the rule, it's A minus B, A plus B. So I can rewrite this as just A, which effectively, this is my A. So I can just write it as 3x minus 1. It says minus up here, so minus. And it says B, and this is my B. Now this is where you got to be careful. You got to use 5x minus 1 in brackets. Now see, this is why it gets tricky if you don't use brackets. Because I wrote the minus symbol here. Well, I'm going to just do it. See that minus symbol? If I didn't put in the brackets, you'll be wrong because you get the 5x correct, but the minus 1 is incorrect. That's why I encourage you guys to put in the brackets. Keep it separate. Because it was literally, if we just look at it again, this was A, that's a minus. Don't forget this whole thing is a B. Okay, so when you put a minus in front of it, technically this becomes minus 5x, but then this becomes positive 1 because of the negative in front. Okay, and that's the common mistake. I always pick it up. Every time I do this SAC for quadratics, it always comes up. And it's because students don't put in the proper brackets. And that's what I said at the start. I said, poor layout leads to poor results. And sometimes it's not that you don't understand it, it's just that you have poor layout and you keep making mistakes. Okay? If they're consistent mistakes, that's bad. If there's just once off, it's okay. Yeah? All right, so having said that, what I want to work with you today for difference of perfect squares is I want you to recognize that all of that, especially the last two, is still a perfect square. Okay, and how do you know? Is you can see this is A, that is B. That is A, that is B. They're both the same. The only difference is one's a minus and one's a plus. X, that's my A, that's my A. And so you can easily put it back and just say, oh, well, that means this is A squared minus B squared. So what's my A? That's my A. So it'll be X squared minus 1 squared, which is X squared minus 1. Same thing with this one. Looks weird, but that's my A. That's minus B. That's my A. That's plus B. So you follow it. A, which is ABC, squared, minus my B squared, which was 3. So your answer is A squared, B squared, C squared, minus 9. You see, if I gave you this, how many of you are going to recognize that that's a difference of perfect squares? Not many. But if I give you this, too many people will recognize it. And that's not the point. You see, that's what I don't like about students learning where you're memorizing. It doesn't help you. If you understand it, you can do all these because they'll recognize it. It makes more sense. Okay? Same thing with this one. It's the same thing. That's your A. This is my A. That's my B. That's my A. That's my B. The only difference is the minus and the plus sign. So then you can say, all right, well then A is root 3. Notice I'm using the brackets. See, the way I'm sort of showing it to you, that's how I want you to practice as well. Okay? Avoid making those mistakes without using the brackets. So that's A squared minus my B, which is A. Now you can say that must be 3 minus A squared. Easy? Okay. Now, the next question is, well, what happens if it doesn't work out? Ooh, how do I remove that? Uh-oh. Oh, there we go. Next question is, what if I gave you this? Let's do it in the reverse. In factorising, what if I gave you this now? If I said 3x squared minus 1. Now, this is still a difference of perfect square. If I asked you to use difference of perfect squares to factorize it, what would this equal to? Anyone want to have a go? Because I can easily change that and suddenly you're all able to do it. Why is it that if I put a 3, not a 9, not a 4? Because it doesn't square, so what do you do?
Just square root 3.
Yeah. Because if it was a 9, how did you know it was a 3? How did you know it was 3x minus 1 and 3x plus 1? Where did this 3 come from? See, in your head, what you did was you actually went ahead in your head and you did root 9. That's how you got 3. And how did you get the 1? You did root 1. So why is it any different if I just change that 9 to 3? Same thing. So this now becomes root 3 x. Actually, there's no, root 3x and then root 3. Okay, and then that's your answer. Now, logically, why, if you're questioning why the x is there, the reason why is because the formula was a squared minus b squared. So this is currently root 3 times x squared. See, what I want is everything squared. I want a squared. So the only way to get the a, oops, sorry, let me remove that. The only way to get the a is if you actually combined it together and you said, all right, if I did square of the x, that gives me the x squared, then square of what will give me a 3. Root 3. That's why it's root 3x.
So does the square root sign go across the x or no?
Yes. Oh, no, not the x. No. Okay, because what you're really trying to do is this. If I just take a step back, if I went back to this, x squared minus 4, that's what you're used to seeing, yeah? If we're using the formula, I'm going to use the formula just above. I'm going to write it in blue. This is a squared minus b squared. True? That's a formula. Formula tells you once you've got a and b, it's a minus b, a plus b. Yeah? What I'm trying to say is the first thing is it's nice that x is already your a because it's only one term. Your 4, that's not a squared term. That's why you wrote it as x squared minus 2 squared, and then you can write it out as x minus 2, x plus 2. True? Yeah? Now, there's no difference if I had just changed that x and I put in a 3. See, if I put in a 3, the issue is it's not inside the brackets. Because what I want is the formula says a has to be inside the brackets, and you want to square that. Now, the 3 is on the outside. So how do you write 3 as a squared number? Root 3 squared. So that's why right here you would have root 3 squared, and that is x squared. Well, instead of writing it like that, you can write it like this. Root 3 x squared. The same thing. And now this becomes, well, your a. And then you have minus 2 squared. And that becomes your b. That's why it works. Okay, but this is more in the factorizing section. Okay, so the expanding, all you have to do was whatever I'm showing you on the left-hand side. Okay, so that's question 5, 7, and 8. I'm going to give you a couple of minutes to practice it before we jump into factorizing. We'll probably do half of factorizing, and we'll finish it off with the difference of perfect squares, because it's really, really nice and important so that you understand completing the square. You understand completing the square. Finally, you get to what I think is hard, discriminants. You first need to understand these basics. Okay? All right, there we go. So there we go. These are the answers. So you can go back to the PowerPoint, just download, and you get all the answers. Okay, and you can watch the video again just to remind you what I said. And I want you to have a go at simplifying these 4 questions I've selected. Okay, got 5 minutes. Yeah, the highlighted ones. 5 minutes. Let's go. Difference of perfect squares. Notice it's A, B. Difference is the minus and the positive sign. Use the formula. I'm more interested in H, really, because A, B, and F, it's pretty straightforward. I'm more interested if you're getting the roots correct. So these, you can skip the method, you can just get straight to the answer. It's okay. All about that layout. I'll show you the layout for the first one. You can do this. Oh. normally in sort of year 10, then I would enforce it that you actually write it out as x squared minus 3 squared. You get x squared. Okay, so I always follow the format with my year 7s all the way to 10s, and even 12s. It's question method answer. Okay, so you want to get into that routine for year 12.
So is that the same thing we're doing with the other questions?
Uh,
Are we trying to find the difference or the first thing to do?
oh, right. So this is all you need. You can just do that.
Oh no, I mean, okay.
Because if you expand it and then simplify it, this is what you're going to get anyway.
Yeah.
All right, it's about 5 minutes. I'm more interested in H. You can check the, actually, I'll do F as well. That should have gave you x squared minus 5, and this should be 3 minus, 3x squared minus 7. Hands up if you got both of those right. All right, cool, excellent. You learned something. Now, actually I had the answers there. Oh, wait. Let's go back. Is that a different question? Those answers are incorrect. They're somewhere else. I have no idea what that is. Ignore that. Here we go. I must have made a mistake with that one. Here we go. So exercise 3A, I'm just going to move on to get you to do 3B now. But that was 3A. 3A was 1, 2, 3. And then you had 5, 7. So notice 7, this is the perfect square. And you just did 8. Okay, so you just did 8. That gives you a sort of understanding of expanding. What you're doing now is on to the next exercise, factorising, and we're going to keep it simple because we only got about 12 minutes or so. So let's jump to these ones. Factorising, we understand that it is the inverse or the opposite of expanding. But notice when you're expanding, you are timesing. So that means factorising, the inverse has to be dividing. Okay, and the reason why factorising is harder is because you don't see that process. All you really do for most students is, at this point, you look at it and you're like, oh, 9 and 81, highest common factor is 9, so you take out 9, and you'll notice there's an x in both, so you write 9x. And then, some of you will get it and some of you won't, you just write x plus 9. And you get your answer. Now this is where it gets magical for a lot of students, because they're like, why is it x plus 9? How do they get it? Some students are strong in the multiplication tables and factors, so it's easy. Some of it aren't. What I want you to understand is the process is still the same. You're just doing the inverse right now. So what you're really saying is this. You're saying you got 9x squared plus 81x. When you expanded, you multiplied. When you divided, or when you go back factorizing, you're dividing. The nice thing about expanding is you knew what to multiply. What you don't know what to multiply is in factorizing. That's why it's harder, because you have to figure out what are you dividing by. And that's where you look at these two, and technically the logic is it's 9 times x, and this is 9 times 9 times x. And so what's the highest common factor? Well, the factor is 9 and x, and a 9 and x. And so then what do you say? You're like, all right, so since they both have that common factor, what I can then say is let's divide by 9x and divide by 9x. That's why the 9x's cancel out, and you get x, and that's a plus over there, so that's plus 9, and you've got the factor of 9x out. That's why. Okay, so we're technically skipping all of this step, and we're assuming that from year 7 and 8, 9, you've already mastered to come to here. Okay, but that's the logic. If you times, now you divide. That's where it's coming from. Okay, so I'm assuming with all these ones we can find the highest common factor. So I've highlighted, and we do. Wait, why isn't it working? I think it's lagging. What do you see? Oh, when technology fails. Discard. Let's go back. Okay, here we go. So these are the solutions, finding the factors, and you're dividing, take it out as 2a. What about this one? Anyone have a clue on how they might factorize this expression here? What would you do? You don't normally get this, but if you do, this is one of those questions where you only get in the textbook in year 11. Later on, you don't get something like this. But let's say if you do. Anyone have an idea? What do we do? Yes. Put them in the groups. Okay, you put them in the groups because not all of them have x's. Not all of them are factors of 3, or not all of them factors of 4. So some of them are. So what you can do, and it'll be useful when you learn circles in specialists and later in methods as well, you're going to do the same. You're going to do factor them in groups as well. Okay. So what we can see is, since these two have x squares, I'm going to keep them together. Since this is a factor of 3 and 12. Yep, but I can change this out to be x squared times x, and this is 4 times x squared, so there's a common factor of x squared. Yeah. Whereas this one has a factor of 3 times x, and this is a factor of 3 times 4, factor of 3. That's why it's nice. Okay, so if I take that out, I can rewrite this now as x squared, bracket x plus 4. See, because x squared times x gives you the x cubed. X squared times 4 gives you the 4x squared. Here you can say minus, and you can take out the factor of 3, because the highest common factor there. So negative 3 times x gives you negative 3x, and negative 3 times positive 4 gives you a negative 12. So you notice here, negative 3 times 4 gives you negative 12. Okay, so don't make the mistake of just putting a minus there, because that's wrong. Okay? And then the nice thing is, hey, look at that. This is one term, that's a second term. But what's the common factor? They both times an x plus 4. You see, if you really notice it, this is just x squared times x plus 4. This is minus 3 times x plus 4. So they both have a common factor of x plus 4. So you can still do the same thing again. You can factorize these two and say, all right, well, let's factorize it to be, take out the x plus 4, and in your other bracket, you have x squared, and you have minus 3. And if you really want to break this further, what do you notice here? X squared minus 3. Difference of perfect squares. So therefore, you can now write that as x plus 4, x minus root 3, x plus root 3. Okay, and that is a skill that you are going to be required in those kind of application questions. They're not going to tell you, you're going to have to pick it up yourself. Okay, and that's why it's difficult. And you know, it doesn't always come up, but that's what I'm saying. Try to picture these little details that come up, those little details there.
So if we just left it with the red writing, would that be correct or not?
Yeah, it works. You can still solve your solutions. You don't actually have to break it up into this. Sometimes your questions will ask you to do that. Then you would have to have it. But most cases, this is sufficient for you to solve in Sketch. Yeah. All right, there we go. I think I put out the solutions here. So if you didn't copy it down, it's all here. It's wait, did I make a mistake? No, I left it there. Maybe I should just tell you to remember. You can factorize this further to x minus root 3 and x plus root 3. Okay, just remember that. All right, excellent. Now, I'm going to leave that there, and whatever you can do. These are the questions. Please copy that down for your methods. Exercise 3B. We're going to carry on in the next session to make sure you get difference of perfect squares factorizing. Okay, especially factorizing trinomials. That was a big thing for year 10s last year. And I always find that year 10s struggle with trinomials. So we're starting off easy. It's going to get harder when we get to J. But for now, just revising year 9 and 10. Now, if you still have any troubles, it's a good time to come see me early in the year. Make sure quadratics is down. Because if it's not down, you can't do cubics and you can't do the rest. Okay, so if you have troubles, I'm on the other side. Got my timetable, schedule, let me know, and I'll write in my diary.
So can I just do the ones listed in the corner?
Yep, just do the ones, question 1, 2, 3, and 4 is okay. You should be able to do 5 with difference of perfect squares, what I taught you. So you should be able to do 1, 2, 3, 4, 5 at home. Maybe 6, 7. I think 7 and 8 is where. Wait, let me just check. 7 and 8. Oh, I moved on. Oh, how do I switch to the next screen? No. I thought there was a button that you can switch. No, I don't know. All right. No. That's what I'm going to do next session, by the way. So if you download the PowerPoint, you'll know what I'm going to talk about next tomorrow. Move on. No. Okay. This is what I want to go to. But I think... Oh my god. Yes. So 7 onwards is factorizing trinomials. That's what I really want to focus on. Make sure you get that. Yeah, I don't care what you do. Huh?
The last 4 questions.
Yeah, so 7, 8, 9, 10, leave that. Leave that. You should be able to do 5. I think 6 might trip some of you. 6 might trip some of you with difference of perfect squares, and I want to spend some time talking about that too. But 6, 7, 8, 9, 10 is really the key, because without this, you can't sketch. You can't solve for x and whatnot. So you need this. You need to spend some time. Like if anything, spend most of your time learning how to factorize. Okay? Otherwise, in the meantime, you can start off easy. Do the 1AB, 2AB, 3A, and 4H. That should be enough to sort of get an idea what factorizing is. 5, 6, 7, 8, 9, 10 is difference of perfect squares. I'm going to be back. I swear there has to be a quicker way. You know what? Maybe the quicker way is just do this. There we go. Yeah.
Do you know what we're going to be doing next week? Wednesday, Friday.
Wednesday, Friday?
Wednesday, Thursday.
In terms of topics?
I'll be away.
Oh, you'll be away? Alright. Let me have a look at the course outline. What was I meant to say? A and B is useful for C.
Yeah.
D and E is useful for F. That's how it works.
So watch. Do I have to do the questions for that?
No, you don't have to.